Hello, my name is Sam Kleinard, and my final project for Virginia Space Coast Scholars is on LADEE. The previous slide showed you the goals for LADEE. The main focus of this mission is on the Moon's exosphere and the lunar dust environment. There are two reasons it is important for us to study this. First, scientists worry mankind's exploration of the Moon may change the Moon's exosphere. Second, gathering information on the Earth's moon can help us learn more about the moons of other planets. So let's talk about how NASA plans on obtaining the necessary information. The mission has two groups of people working on it. They are the scientists and engineers. I have decided to focus on the engineering aspects of LADEE. However, the scientists and engineers have to work together in order to complete the mission. The scientists have made a list of scientific objectives in order to obtain the data they need. They give this to the engineers, who figure out how to achieve each objective. Scientists and engineers have to continue to work together throughout the mission in order to stay on track. Here are the scientific objectives for LADEE. NASA employs people from all walks of life to design and build the launch vehicle and sensors. NASA's employees can be separated into engineers and technicians. There is no clear line between them, but in general, engineers hold 4-year degrees or higher, and technicians hold 2-year degrees or lower. Engineers do more of the designing and thinking, and technicians do the manual work. Here are some examples of the types of engineers and technicians that NASA employs. The engineers come up with a design to accomplish the goals of this mission. Collectively, this design is called a systems model. Here's an example of a system model for LADEE that I have created. Engineers have a lot of options when they design a system. They have to figure out what kind of technologies they need to accomplish the mission. A major contributing factor to consider is whether the technology already exists or if it will need to be invented. NASA usually utilizes existing technology when possible because it is cheaper. There are two main questions that must be considered to determine the technology that will be needed for LADEE. What platform will the mission employ, and what sensors are needed to obtain the necessary data? Let's consider platforms first. We will examine 3 types of platforms. Each platform has its advantages and disadvantages. For LADEE, an orbital launch vehicle is the only platform that will work. This is because the platform used by LADEE must be able to reach the Moon, and an orbital launch vehicle is the only platform with this capability. The next decision to be made is which orbital launch vehicle will be used. LADEE is going to use Orbital's Minotaur 5 launch vehicle. I discussed previously that NASA tends to use technology that already exists to save money. The Minotaur 5 is a new launch vehicle, but its 5 stages are based on previous Minotaur launch vehicles. So, it still saves money by combining older technology with new technology. Here's a brief overview of the engineering aspects of the Minotaur 5 launch vehicle. Now that we have talked about platforms, let's move on to sensors. This is when the engineers and scientists have to work especially close to each other. By reviewing the scientific objectives, NASA's engineers have determined 3 main sensors that can complete the mission's requirements. In determining this, a major consideration is how much each of the sensors costs. There are several ways to reduce the cost of sensors. Most notably, if the mission can use previously designed sensors, it will be cheaper. This is because a lot of the money spent on sensors is in the designing and testing phases. Here are the 3 sensors used by LADEE, and following I will tell you the purposes of each. The ultraviolet invisible light spectrometer analyzes the light signatures on various materials in the Moon's exosphere. It then can determine the composition of the materials. The neutral mass spectrometer records the change in the lunar atmosphere over several space environments. Lunar dust experiment will take samples of lunar dust from the atmosphere and analyze them for electrical charges. This could help answer a question from the Apollo program. The astronauts witnessed pre-sunrise glow from the Moon. The hypothesis is that they saw a glow coming from lunar dust charged by the sun's ultraviolet rays. In order to save on the budget even further, NASA considers additional technologies that could be incorporated into the mission. The spacecraft and launch vehicle make up 2/3 of the total budget for LADEE. It makes sense to add additional technology if there is room. There is one technology that has been added to LADEE, though it was not completely necessary for the mission. That is the 2-way laser communication. This will provide NASA with broadband communication to the Moon. Although not really an additional technology, LADEE will introduce the new modular common spacecraft bus. This spacecraft promises to make the transition from custom designing every spacecraft to multi-use designs and assembly line manufacturing. By adding these additional technologies, NASA can test and demonstrate them without using money to send another mission to the Moon. Here's an overview of the 2-way laser communication and spacecraft bus. I would like to take this time now to say thank you to Mr. Ruff and all the other VSCS staff that have made this program possible. I have learned a lot over the past couple of months and look forward to applying my newfound knowledge to my life ahead. I had a great time and I hope to see you this summer. Thanks again, and for now, goodbye.